Details of the session and the detailed agenda and speakers are on the screen now. I'm going to let Jim go through that. However, before we start with the content, I'm going to remind you that this is a hybrid event. If you're online, your microphones will remain muted for the duration of the session. But if you do have any questions or comments, please add them to the comment section of the Hop-in platform. We will also take questions and comments as we go through from the people in the room. I need to bring to your attention the fact that buildingSMART is committed to ensuring that participation in the development of standards is unrestricted, and that the process for their adoption is transparent, and that standards that are developed do not favour any particular provider, but are open, non-binding, and accessible to all. Please take note of our antitrust code of conduct shown on the screen. With that, I'm going to go back to the detailed agenda and make it full screen and ask Jim just to say a few words.
Thank you, and welcome to everybody, both virtual and in person, to this session. My role is very simple. All I have to do is announce each of the presentations. We're going to have a brief introduction by Adrian, and then Christophe is going to talk briefly about the current activity to transfer, I guess, or what's the right word, to activate the process of moving IFC 4.3 into the ISO process. Then there's a few more specific project reports on some of the activities that have been going on between the road and the railway room. So it's really great to have both rooms together. And I thank the railway room for joining us in this occasion. So can I just hand over to Adrian? Thank you.
Thank you.
Thank you very much. I'm not sure if I should start singing now, but could you switch to the... Yeah. So, thank you very much for having me, and it's a pleasure to show a short presentation about our expectations as a client. When I was asked to do the presentation, I was not sure, shall I do the usual stuff, telling we need standards, we need open BIM, etc. So I thought, no, I'd do it differently, and I did some facts. It's not alternative facts, they're real facts. So if you could just go to the next slide, please. So on this slide, you see fact number 1. These two persons are most important people in the business, our customers. So, even better, they are our customers, and we have to remind you that we are a public company. Most of the train companies are public companies, and we're spending taxpayers' money, so your money. So we have to be efficient, we have to be cost effective, and we have to use our monetary assets very, very wisely. And of course, we have to punctual as well. Next slide, please. Fact number 2, we have so many built assets. At SBB alone, we have 3,500 buildings, 8 water plants. We have, I don't know, 35,000 signals, 3,500, 24 kilometers of tracks, etc. So we have to fulfill, or we have to have a good analog infrastructure because people want to arrive on time. And we need to have a digital infrastructure. And digital infrastructure for us includes standards as well. We need to have good standards for our digital infrastructure. Please go to the next slide, fact number 3. That's Zurich. Of course, you recognized it at a glance. Fact number 3 is there's not a standalone infrastructure. Especially in the rail sector, there's not a track without a signal. There's not a track without a tunnel, at least in Switzerland. There's not a track without a bridge. There's no bridge without a road. There's no tunnel without a building. So there's no standalone infrastructure. We need to combine all of these infrastructure assets to reach a common consensus. You can see it on the picture. They're quite good. There's a bunch of tracks. That's a Zurich main station on the other side. But I think you can see the maintenance facilities on the left hand. You can see the real estate buildings, some of them belong to SBB. Only the beautiful ones. The other ones are not from SBB. And a lot of tracks, a lot of signaling, a lot of cables, a lot of whatever. And it has to work together. Must work together. Let's go to fact 4, please. Following the 3 facts before, fact number 4 is we need reliable, applicable, and comprehensible standards. As said it on Tuesday, you don't need to have a PhD to understand what you're doing. The foreman on site has to understand his impact on infrastructure, on the digital infrastructure, on the standard, etc. They must be understood. They need to be applied by all, I have to put it in brackets, by all participants in the value chain. Leading to fact number 5. As I said, we are a public company and we need to minimize risks in everything we do. We have a lot of pressure monetary-wise. We have to save, at least for example in the BIM program, we have to save from 2025 200 million francs a year by using digital standards. And I'm not sure 200 million francs is around, I don't know, 200 million euros, Canadian francs, 250 million or 300 million Canadian dollars. So that's quite a lot of money we have to save by using digital methods. And I can tell you, we have controllers behind us who want to see these figures. So that's not a very comfortable position, I think. So, and the most important point is we do build for operation. As a client, we don't care. Well, of course, we care about the planning and the construction, but we need to have a standard for the operational phase of our assets and for the interconnected phase in the operation. So next slide, please. Thank you very much. And if you ever come to Switzerland, give me a buzz. Thank you very much.
Thank you very much, Adrian, for that overview and that insight into why we're here. I'm going to hand over to Christophe now, who's going to explain the process that we're going through currently to move IFC 4.3, the extensions for infrastructure, into the ISO process and bring us up to date on that. Thanks, Christophe.
I think it was important to report here to the stakeholders about where we are with the ISO process for approval of IFC 4.3. And I'm committed by buildingSMART to supervise the process with ISO from the buildingSMART side, the process of approval of ISO, and of course, Thomas is the governor of the process in ISO. Okay, so where we are, first of all, from buildingSMART, the process is to produce to ISO so-called production standard, and we have to follow this full process regarding the protocol we have between buildingSMART and ISO, about to go as fast as possible in the validation process. So we need to obtain in buildingSMART International the status of production standard to be accepted as a DIS project in ISO. That is very important to know that. So we produce in first the IFC 4.3 release 4 issued to ISO. Where is the 17th of March? So we can move on. Yes, next one. Yes, and it was happened during this spring, and we created in the Joint Working Group 12 led by Thomas, an editorial committee to analyze the documentation. And then we have the last step of this process, the 29th of September. We decided, with the unanimity of the expert of ISO, to proceed to the DIS ballot. It's important because DIS ballot means that in the process of approval, we are winning 6 months of discussion, something like that. Again, next one. Okay. So what's happened between June and the 19th of September? We create this editorial committee. We have several meetings on that in order to verify the content of the documentation delivered by buildingSMART, and to verify it is in line with some specification coming from ISO. And the last step for the editorial committee, which worked during all of the summer, was the 6th of September. We decided to say that the list of modification to be embedded in the documentation provided by buildingSMART, and that is based on this decision that with September 29, Joint Working Group 12 decided under anonymity to go to the DIS ballot. Next slide, please. I want to report also not only on the process, but the content of the process. Next slide, please, John. It's not moving, huh? There is something. Okay, so by memory. So we have a discussion. We split in two parts, or split in two parts. The first one was to verify that the HTML documentation is working together with the different parts of the chapter, but also with the criteria to verify if we can obtain the continuity between IFC 4 and IFC 3. And we consider that the target was to say everything working in IFC 4 has to be working in IFC 4.3. Very important, because the quality of the standard is there. If we make the difference between authoring tool and property schemer, we need to have this continuity and to break what is done by the software vendors and by the end user about using the standard. So we proceed in this way to start with the content of the documentation, where we have a part is chapter 8 or 7, I don't remember. It is on the slide. With all of the change log. Change log is explaining in the documentation what are the modifications of the structure of the standard, and then to verify if we are creating a break in the structure or not. We work very closely with the French with the French organization of standardization, AFNOR, with a process to verify that. It was very interesting for two aspects, that it was a way to verify that the quality of the documentation in terms of continuity and the link between the different parts of that is working very well. The information regarding the change log was verified with the matrix. If we can go to the slide 7. Slide 7. So on the right part, you have the Annex F with list of change log. It's a challenge, really. So the list of change log with 3 categories. Green is new, blue is modified, is red is deleted. And the next one we have, and based on that, for each one we verify what it is new in terms of RTT, attribute, where rules, inverse, the same modification is same deletion. In this case, to verify where is discontinuity. So this work was done during this summer, and the result is next slide. Next slide, please. That's the list of modification on each entity needed to verify this continuity about what it has to be deleted, not deleted. Deprecation was mentioned, and what it is in modification is if it is in line or not. Because, for instance, if we change the place the rank of attribute, you change the compliance with the standard. So we verify that, and we come back about that. The list of modification there. Next slide. It's not so much. In terms of quality, it means that it's normal to have 10 to 15% of modification of that. It was less than that. So that means that it's also proof of the robustness of the standard. Next slide. And we make a second, we make a second type of modification. It was what we discussed with Jim about editorial aspect. Editorial aspect would mean only explanation about the content, and we make some improvement of that about to be more clear about the impact of this news of this standard about the domain and so on and so on. And mainly, I mean, the main modification was regarding the explanation about the implementation of alignment, geodetic, and so on and so on. It was important in the process because it was a way to give confidence about in direction to the expert of ISO about the quality of the standard, but also to have some explanation of how to use the documentation. And it's really a way to facilitate the approval. So we are now produce a documentation specifically to the expert to explain this kind of modification. It's the first documentation. And the second one, we were in situation to deliver an HTML release of the standard to be approved by ISO. Next one. And it was a complete explanation on site through PDF file about the list of modification in the standard. So now we have a branch in GitHub in order to be able to generate a collaborative approach and discussion in ISO about the way to approve in the DIS palette. Next slide. And in the website of buildingSMART, you have the information about what is the release under the ISO process of DIS voting, which is clearly specified here. And you have 2 releases in progress, one based on additional specification arriving after the process of ISO DIS, and preparing the next step of IC 4.4. So it's very clear, I'm saying that for the software vendors, what it is under the control of ISO. It's release of the release on the page. The new one is not supposed to be adopted by ISO right now. It is in progress, but what we can say, and the job we have done in ISO is really to verify that there is no risk for the software vendors to work already to implement IFC 4.3 as it is, because what is going to happen with no risk to break anything and so on. So it's very important for that. So next slide. And we introduce something new to be verified with buildingSMART, to have a common definition of something very important for the next step of the standardization, to have a real definition of what does it mean deprecation. Deprecation means means that it's a warning to the software vendors that we are going to change the standard in the future, and to say until now there is no change, we can continue, but when you are going to have a new release, take that into account to modify their approach. It's not only for the software vendors, it's also for the end user about their own application. 2 definitions we added about the question of forward and backward compatibility. I don't remember the saying. The backward compatibility means what we are saying. It's a target. IFC4 are still to be able to work in IFC 4.3. Forward compatibility is much more difficult, and personally, I'm not in favor of that, to say that IFC 4.3 could be able to work on the IC4, but it's much more difficult to obtain, and I think is even not a real perspective, because it's too complicated to make the real scope of the modification with new entities and so on. So I think that from my point of view, and I not recommend to buildingSMART to go in this direction because it's too much complicated. And the last one is something to be checked in the future, and I learned that from the process from Thomas, is the question of the status of the PSET. That means, do we have to maintain the continuity of the definition of PSET and so on? until now, and I am speaking under the control of Thomas, it's not part of the scope to be approved by ISO. Except that now, with the evolution of the standard, we cannot separate the standard to the element of properties, definition, and so on, because we are not managing only a standard about geometry. We are managing a standard based also on managing of the properties, because all of the most of the usage of the standard IFC for the calculation is for make any measurement and so on is based on the properties, not only by geometry. So that reason, I think we have to rethink about a little bit about that. Next slide. Yes, very important. I want to say that because it's also the quality of the job done. A very good job done by Thomas Krunen. I want to say that, very open and so on. It was a very way to facilitate the works. It works very well. And a special thanks to also the French team about AFNOR, because they was also very open. They worked very closely with Thomas, and I think that it was a very good job done. And we can say that the standard is very, very robust. Thank you very much for that. Last slide. And for me, it's important to say that I want to say that here, a very special thank to Richard, because it was someone who helped us from the very beginning about this process. And I think we have to dedicate if we succeed to the approval, to Richard, because it was something to be done done with him, with the support of him, and I'm very proud of that. Thank you very much.
Thanks, Christophe. We need to keep this moving forward fairly rapidly. We apologize for the technical mix-up there. We're now controlling them from over here, the slides, because the control wasn't working here. So our next speaker is Ronald, talking about the alignment-based reference view. Thanks, Ronald.
Thank you very much, Jim. Thank you, Christophe. First of all, I can tell you that Christophe talked about IC 4.3 documentation, which is going to ISO the specification, and the alignment-based reference view is a part of that. It's referring to that to the specification, and is about the principles of you need for alignment based on that specification. It's a part of that. It's referring to that specification, and it is a joint effort of the rail room and the infra room. You're right, yeah? Yes, I would like to tell you about the alignment-based reference view, that you have an understanding what it is and why it is important for you. And the alignment-based reference view is, from one hand, it's about the information you need as a software vendor to implement the alignment principles of IC 4.3, and it has some constraints for that. Which constraints do you have to understand to implement in order to be able to have the implementation ready for certification? And if you have that ready, then it's important to have to use it for business cases, that you can have business cases based on that implementation. And there are two deliverables for that. So first of all, the constraints to define what's inside of the scope of the alignment-based reference view. And the other thing we delivered from our team is the test instructions. And these test instructions are not covering the whole scope of the alignment-based reference view, but it's telling the software vendor what kind of capabilities can be tested or are expected to be in the implementation. And there's also some guidance for the stakeholders to understand what kind of capabilities can I expect from the software vendors when I have a software vendor who has implemented the alignment-based reference view. We can go to the next slides, please. So we started with the objectives of providing the information needed for the software certification services in order to have the right specification for implementation, and to ensure interoperability, and to be sure that the specification is based on a user demand approach. That means that the whole efforts which has been done in making the IC4.3 and developing it and deployment, that these things have to be taken into account. And they were also used for the test instructions, so they were based on these experiences and these results. The thing about interoperability is that there's a new MVD policy from buildingSMART International, and it says that you don't have, it's not possible to have 500 different MVDs, because software vendors don't understand what they implement, but you have one base MVD which is common for everyone and which should be implemented. And if you have that implemented, then you are able to ensure the interoperability between software platforms. The next slide, please. So the alignment-based reference view is a so-called base MVD, and there will be 3 base MVDs, maybe in future even more. At this moment, we only have the reference view, which is based on IC 4.1, I think. And the alignment-based reference view is based on IC 4.3 version. There maybe in future there will be a design transfer view as well. That's not for me. I don't know exactly when it is scheduled. But the alignment-based reference view is based on is covering actually the geometrical, but also the semantical definitions you need in order to implement alignment in the software. So next slide, please. So I would like to say something about the timeline, because we started the work in October 21 with having a Paris workshop. So we have a lot of experts together, from domain experts, technical experts, and the buildingSMART management, to understand, okay, what's our scope, what are we going to develop. And we decided to have, of course, the alignment-based reference view definitions, the scope definitions ready in the beginning of 2022. Was a joint effort with the rail team. And we decided to have 2 kind of batches for the test instructions, because we had too limited time to make test instructions for which would cover all domains of the alignment-based reference view. So we started with the basic ones, which are really typical for IC 4.3, which is demanded by also the domain experts for rail and infra. And then going to a bit deeper into that you understand what I talk about. And as we were moving, there were a lot of developments also inside buildingSMART International in terms of software certification services. And now the delivery, what we have in March, is now being reviewed and fine-tuned by the implementers team. In order to define the final constraints for that. But in the meantime, we are also working on new test instructions. There are test instructions being produced now, which will be ready at the end of this year, for aggregate structures for pavement. And there are also new test instructions planned for bridge alignments. So we have to live for the project plan, and we hope to move on with this. And Christophe will say something about that later on. You can go to the next slide. So when we talk about alignment, so I was joining another session this morning from the wheel room, and they had some business cases, and they said what's important for us is to have the linear placement. We have the horizontal alignment. We have to understand from how some elements are positioned, aligned to how they are linear positioned. So it's about linear positioning, it's about geo-referencing. So these are very typical things which are important for as well as the infra room as the rail room. And if you look at, there's a lot of overlap, but there are some specific differences, like In the infra room, you have also principles about super elevation, and for rail you have the cant. So super elevation is about that you're having some vertical differences, and the cant is you have some an angle in your alignment which you should take into account. And so it was important to have these principles specified as part of the alignment-based reference view, so that this should be implemented by software vendors. This should be understood, and it means that software vendors should understand where can I find the specific relationships inside the IC403 scheme, and they are mostly represented by concept templates. So it's a matter of defining the concept templates we will need for the alignment-based reference view, and some extra constraints of doing this. So next slide, please. Yeah, and of course there's also some contents which are important, like signaling, energy, telecommunications, and directives, especially for the rail, which they would like to see to have implemented. So these are the things which are, when we talk about what's inside the alignment-based reference view from the content point of view. If you go to the next slide, please. Yeah. So what I said is, so in effect, is the alignment-based reference view is now a selection of constant templates, and this also for everyone available. I have put a link on this in the sheet, and you see that. From the fundamental concepts, which templates are part of alignment-based reference view, which ones are part of the reference view. And there will be some extra constraints, which is now being discussed in the implementer forum in order to finalize that. And this slide shows the domains which are part of the alignment-based reference view. It's we're talking about alignment reference, aggregate structures, bridge structural earthworks, energy, signaling, and also kind of telecommunications and geotechnics. And you must understand that for all these, this scope which is on the slide, the concept templates have been selected and will be used for the configuration for the software certification. Then at the beginning of the presentation, I talked about test instructions, because the test instructions are also provided as part of this development. Yes, but I don't see a slide. and this slide shows which test instructions have been completed. So it's about alignment reference, that you can validate as a software vendor, how you are sure that you have implemented super elevation or can't correctly. Track structures are also ready, and we are, what I said, road structures will follow this end of this year, and we would like to add also the bridge specifications related to alignment. Can you go to the next slide? Yeah. So the process is a joint effort, but it's also a joint effort of domain experts, technical experts, and software vendors. So we had on an individual basis some software vendors also in our team to check if some things are feasible, and the whole development is also be under review in the implementer forum, which is consisting of the software vendors. So it's very important to have a feasible implementation and a feasible specification, so that the IC403 for alignment-based review is implemented in as much as software tools as possible, that you as a stakeholder have a broad choice and can make your business cases based on that. So we have delivered the alignment-based reference view to the software certification teams, and because IC43 is now published as an ISO standard. That means that if there are any changes based on the test instructions, it would be a change of on the IC43. So that means that we should have the test instructions based on the same scope, and if it's not, then it should be in a new kind of change process, which is handled by the implementers forum. Yeah, the test instructions have all of them have the same format. It says something about the intent of the test, what kind of capabilities are tested. It's saying about the kind of, is it an import, is it an export test? It says something about the preconditions and the validation criteria. So what is being validated, which kind of rules, and what kind of output is expected from the validation process. And sometimes the data sample has been provided for that. And test instructions can be either standalone, or at least for the real room, it is based on previous test instructions. Test instructions are built on previous test instructions, so that you can follow as a software vendor some steps from how can I build up my implementation, and how can I test that these things are working, and you can build on that on these sample sets. Actually, things that you can use of the same sample set, and then you can test it accordingly. Yes, the test instructions are modular configured, so it can be expanded, and it can also be expanded every time. So if someone is saying, I would like to have something tested, then we can make additional test instructions, and it can help both the software vendors as also the stakeholders to understand, to align the expectations about that. And but it doesn't say anything. It doesn't change the alignment-based reference view as being the specification of what should be implemented. It's only helping you to understand if something has been implemented correctly. Yeah, here there's a GitHub repository where you can find these test instructions yourself. And I have some example of how does it look like. So it's very specific, specified. For instance, this is an example of 2 alignments without GANs. And the thing is, on how, what should you do as a software vendor? Where can you find? How can you validate that you are able to produce these 2 alignments? And it's starting with the scope settings. It's saying about this test instruction is saying about the export of the data based on the implementation. It's saying what kind of entities should be used from the IC scheme, what constant templates should be used for this one. So it's very specific. And then if you go to the next slide. It says also something about the model data set which can be delivered, so then everyone can check it themselves, and also the expected results. So there are some tables with some values which you can check if this work for you. And this is something saying about the rules. So what when we're talking about alignments, for instance, saying. Be sure that alignment layout structure verified. Because we are talking about 2 alignments without GANs, be sure that you have 2 alignments in your file, things like that. And there are some tables which showing the expected results. So it's very specific, and should be easy for everyone to understand and to use how this works. But what I said, it's not covering everything. It's just checking some principles which are important for real and for infra room to implement. So the last slide. So alignment-based reference view is now part of IC 4.3 because it's the selection of the constant templates which are inside the IC 4.3. It's already merged in its HTML documentation and published by buildingSMART. International, and what I said currently, it's being reviewed and fine-tuned by the software vendors in the implementer forum in order to finish it. And yeah, and this is very important to have it implemented, so the various stakeholders from the infra room and real room can use this and to build their business cases on it. So if you have any questions, you can contact me. And I would like to thank you, and you can move on with Evandro. Oh yes, of course.
I get to pass the mic to Evandro. Evandro is going to talk a bit about a collaboration, the infra room and the rail room working together and delivering 4.3. Thanks, Evandro. I should also say we'll try and make time at the end for questions, but we need to keep on moving through the presentations. Thank you.
Thank you, Jim. I'll try to speed it up. I have a lot of clicks to do, so if you want to put it, I'm happy to do them. Okay, hi everyone. Evandro. Probably some of you knows me. I was heavily involved in the infra and railway room in the past, but this is my first summit as buildingSMART full employee. So very thrilled to be back. I will skip the introduction. These are the things that I care about in my daily business at buildingSMART. So feel free to get in touch. The idea of today is we saw in a chronological order, we saw the development of IFC 4.3, how infra and rail cooperated on that. We saw the spin-off project, let's call it spin-off project of the initiation of the creation of the alignment-based reference view. And now I wanted to show you how these things evolved, and they're coming together with the support of BSI, and they're growing, and with support of vendors also to get to the IFC 4.3 alignment-based reference view. So we're going to talk about the IFC 4.x implementers forum. We'll briefly talk about the BSI validation service, how they interact with each other, and the relationship of these two initiatives or services, whatever you want to call them, with the BSI projects. And for this reason, I like to have an understanding of the audience. How many of you, by show of hands, have been involved or are involved in a BSI project at the moment? Okay. And I guess all the others are not involved in any BSI project, right? Okay, so I'll try to keep these simple. Again, the objectives are to learn about the implementers forum validation service and how, especially how for the people that are involved, at least in the projects, how these solutions can be leveraged by these projects. So first and foremost, the IFC 4.x implementers forum, fancy name, I know. But in short, ACE is a collection of vendors that are coming together on a weekly basis to test, jointly test the standard, and also end users are involved and IFC experts all together coming in the same venue to try to challenge the standard. The objective, of course, is to accelerate the adoption of the standard and the implementation of IFC 4.3, and also to inform the community on the status of the implementation. So there are internal, very technical meetings, and every quarter we have let's say a plenary in which we provide the metrics and the status of the implementation. There are more than 20 vendors involved, more than 20 countries, and all the 4.3 domains are covered. So it's a BSI initiative, it's a big umbrella covering all the domain of 4.3. This is how it's structured. There is a forum coordinator, which is myself, and a technical coordinator, which is Peter Bonsma. And then vendors and users are both part of the same initiatives. They can do multiple things. All of them contribute to the roadmap of the forum. All of them can create tests. Usually, this is part of the BSI project activities. We will see them in a few seconds. But also defining rules, meaning agreements and constraints on top of the schema. These are the key part. And then vendors have the chance to take and execute tests. So these are the responsibility. Keep in mind the diagram on the right side, because that's the part 1 of 3. We will see this evolving throughout the presentation. So these are the activities, the main activities of the implementers forum: writing rules and taking tests to produce IFC files. What about the validation service then? Issue with an image. You should have a screenshot of the validation service. I can probably show it to you later. It's a web service, free, online, for validating IFC file. It's developed by buildingSMART with the help of software vendors and with the help of the projects. It provides a judgment of conformity, so to say, of a given IFC file towards the IFC specification. So quite similar to the screenshot that they should have seen before. This is how it looks like at the moment. The IFC file is valid when it conforms to, let's say, many things. First and foremost, the syntax. You have an example here, an unclosed parenthesis. Okay, this is a syntax error. And this is checked by the syntax module of the validation service. Then there is another module checking schema. I guess in this case, it's a global ID attribute, which is a string instead of an integer. Okay, this is a schema mistake. And then there are a lot of other, let's say, informal proposition or implementers agreements, meaning further constraints on top of the schema. They have various form at the moment. Sometimes they are simply text inside the definition of an entity, or they are informal proposition, sometimes concept templates, general usage, overriding concept templates. So there are many forms, but the idea is that there are two major distinctions. This is an example of a current informal proposition. Every edge shall be referenced by the loop of the face. Fairly complicated. This should be an image showing that, but something is wrong with the pictures. And this is another one, actually, the kind of agreements that we are finding in the forum. Agreements of, for example, there must be exactly one IFC site. At the moment, there is a list of agreement. It's a list of plain English agreements. What we are trying to do is that we are trying to transform them. Actually, we are transforming them into rules that can be read by humans and machines, so that the validation service can automatically check that the file actually have one IFC site. So what the validation service is focusing at this moment are these two: implementers agreement, informal proposition, concept template, general usage, whatever defines further the alignment-based reference view. Additionally, probably it's not important, but good to mention, the BSI validation service checks the conformance with BSTD. This is more, let's say, user or project related, or user focused. Yeah, that's the image of before. Something messed up with the image. So that's the face looping twice. So just to let you know that the validation service can check the file against a BSTD. So in short terms, if a file comes along with some definition of a BSTD and with a URI pointing towards a BSTD domain, the validation service retrieve the domains from BSTD and check that the information in the file are actually compliant with what is written in BSTD. Again, something wrong with the image, but take a look at the diagram on the right part. So the second part of the diagram is that if you remember the first part, now you have the validation service coming into the picture. So the validation service is using the rules defined by the implementers forum to check the IFC files. To complete the picture further, what is the relationship with the BSI projects? Well, the BSI projects can contribute to the validation service by writing rules, and this is actually what Rail is doing. I think they will explain it in the next presentation. So they can write rules, they can submit tests to the implementers forum, as Ronald was mentioning, and these tests are referencing those rules. So they will create tests with a description, a title, a data set, and then they will list the same rules that the validation service will use to check the files, which are the products of the test itself. So by doing this, the projects are actually test the standard, and also can get some IFC sample files that are validated by the service at the same time. And most importantly, they will directly contribute to the software certification mechanism that is based on the BSI validation service, because the rules that the project will be making will be part of the same validation service. In this context, again, I probably stressed this before, a rule is a constraint or further specification on top of the schema. And I think this is, I'll go quickly over this, but this is a graphical explanation of, a graphical summary of whatever I just told you. So syntax, schema, informal proposition, these are all the checks that are happening on the same file. Implementers agreement, concept template, general usages, again, any constraints on top of the schema that is function of the schema version and of the MVD. And then, yeah, you see BSDD is a little bit on the edge. BSDD is on the edge between what is checked on the IFC file to make sure that the IFC file is legit and can go from one software to another software. Checking BSDD content, checking that my file contains the objects that I needed, the properties that I needed, the materials that I needed, it's something that is project specific. So I'll make it very simple. The first part, I can do it without knowing anything about your project. You give me your file, I can do the first part of the checks. And this defines the valid IFC file. The second part, I can only check it if you provide some information on your project. Yeah. So just to stress the fact that the validation service is focusing on the upper part and a little bit on the BSD, as you saw. This is probably the most interesting slide for the project. I hope that the graphics are not messed up, otherwise it will be impossible to read. But just to give you an idea, so the validation service, as I said, is a free, open service that anyone can reach today. If you head over to validate.buildingSMART.org, you can log in with your BSI account, and you can give it a try. You can upload a file, and you will have the errors. Of course, it's a beta version. We are building it, so we're happy to hear your feedback, suggestions, and proposal. We just had a very interesting session, a workshop, a bring your laptop workshop in the technical room just this morning. It was great, a lot of feedback, a lot of vendors uploading and checking their files to make sure that the implementation was correctly. The idea is that the web service, the web platform is tracking a BSI GitHub repository. So the code and the rules that the system is using to check the files are openly accessible in a BSI repository, together with this part, which is probably less interesting, which is the front end and the back end of the service. Okay, that is also openly available. So let's say the infrastructure and the content of the validation service are both openly available. And what Railway is doing, and Tunnel soon, and probably Bridge if they want, any BSI activity can branch this repository and have a sandbox to create and refine their own rules. So we made a setup so that as soon as they create a branch, they will have another website, which is the same website / sandbox, whatever, with a specific address that they can use to play and build their own rule. So this is to provide also a nice user experience without digging into the code too much. And then there are other two repositories. Actually, another one, which is the one of the IFC 4.x implementers forum, which is the one that is used to capture all the test cases. All the test cases data set, the reference files, if they are available, they are in another repository completely independent of the validation service. And in a similar way, Rail and all the other projects will fork these, will create their own tests, will create their own definition. And as soon as they are ready, they can push them in this repository So they will be available and ready to be taken by vendors that then can produce IFC file and put them into the repository. A sneak peek on the future, the idea that we're considering now is that as soon as a file is uploaded here, an action is, a web service is calling the validation service to perform automatically a test on the file. This is just one of the idea that was ventilated in the other room this morning. Yeah, as you can see, it goes to validation. Yeah, sorry, it was really quick, a lot of information, I get it. So I'm happy to take questions. I did this to try to have some space for question. Probably most important things are actually for you the validation service link, the IFC 4.x implementers forum official page of PSI with a little bit of description, and yeah, and some other information that are probably good for you to get an understanding on all this. If you've missed the presentation, the workshop, like the bring your laptop, try to upload your file and validate it session that we had this morning, we are going to do a replica in one of the boiler room, in one of the room below, Mansfield 7, 130. It's the airport room. They're going to host us for one of these workshops. So if you missed it, make sure to join and to bring your laptop. And for any other question, those are my contacts. Please use them. Thank you very much.
Thanks, Evandro. We are running very close to the wind here. So thank you, Evandro. We can't take any questions at the moment, but our next speaker, I'm not sure who's actually leading it. Guy? Oh, Chi online. Great. Okay. Welcome, Chi.
Okay. So good morning, everybody. So I think many people know me in this room, probably. So yeah, I just shortly introduce myself that I'm Zhang. I was deeply involved in the IFC Rail project in the last 4.5 years. I'm currently working in SBB, so the Swiss Federal Railway, and currently I'm still keep the role of the technical coordinator of the railway room. And now, yeah, I'm now presenting the railway business case. So they are in the context of applying IFC 4.3 for railway project. Okay, that's next slide, please. Okay, yes, agenda. So first I will talk about background, then with about this project, applying IFC 4.3 for rail. And then we'll also talk about the methods for requirements, implementation, and validation, the next steps. Okay, next also. Okay, so the background. The background is about what we did and where we are now. Well, in the last 4 years, yeah, we had this IFC Rail project, and we together with the info room projects, and also, of course, with buildingSMART in general, delivered the IFC 4.3 standard. And specifically in the phase 2 of IFC Rail project, we worked together with software vendors and implemented 11 storylines. So these storylines are kind of like quite comprehensive case study that almost involved every aspects of about railway BIM, and some of them also involved some other infrastructure elements. So that's what we did. So all these things actually prove that we have this IFC 4.3 is a valid standard, and we can go further with software vendors to make a useful software. Next. So so we have done all these things. So what I expected now. So first of all, the railway companies will very soon require IFC files as deliverables for railway infrastructure projects. And we also expect a functional software that supports at least the BIM authoring and coordination for railway infrastructure projects. So it's not only about file. We need to really have a useful software. So we, just as Adrian just said, we don't need people to have a PhD degree to understand this IFC file. And then we really need a software to create IFC files and also process IFC files. And also we want to contribute to the general process at buildingSMART to qualify software implementation of IFC. This is very much related to the Evandro's presentation just now. And yeah, this is specifically about validation rules for checking IFC files. And in this project, we also expect the implementation for IFC-based business cases. Okay, next. This agenda page, yeah. Okay, so this project applying IFC 4.3 for rail, the project goal, we would like to continue the very successful cooperation and collaboration with software vendors. And yeah, we need to support the methodology for defining requirements, implementation, and validation. So this is about the method, the process work, and also the tooling. And yeah, we also would like to have 3 prioritized business cases through this process, yeah, with a representative number of software vendors. So we would like to have this thing cover the process from the requirement definition tier, then go to the functional software, then we have a formal method to validate the IFC files, and then at the end, we also expect that this process can be reused not only by these prioritized business cases, but also can be used for other business cases by our stakeholders. Okay, next. Yeah, I think I can hand to Etienne.
Yeah, thank you, Shi. So I'm Etienne Pansart, working with Sistra, sorry, and I joined the railway room this year, so I'm new and I'm very happy to be with you this year. Just to say what we did, I was not in Düsseldorf in 2019, but in Düsseldorf, the railway stakeholders defined that there would be 38 use cases that would be great to develop. And in the applying of IFC for rail, this 1-year project that we started 6 months ago, we decided first to go into the detail of 8 of them, to ask the stakeholders what would be interesting for them to develop, and so we had a short list of 8 use cases, and we choose to select only 3 of them, and to go into the process that she will show and explain us just after. So these 3 use cases have been chosen because they are relevant for the railway stakeholders. That's the first criteria for the selection, but also because they are, we think they could be replicate somewhere else in another domain, at another scale than what we do in the railway. And many of the testimony that we heard today was about we are not doing a railway alone, the standalone remark that have been done earlier today. It's about also building, it's about bridges, it's about viaduct, it's about and we can also find examples in the airport that are very common to the stations that we have on our railway networks. So that's why we think we choose also these 3 use cases or business cases, because first we had an opportunity to develop something relevant for our businesses, but also because it can be reused by another domain, another domain of expertise. And for that, the robustness, the fact that it can be replicated, and the fact that we can scale it was the criteria that we used to choose those 3 use cases. So the first one was the federation of models, and definitely it's not a story of railway. When we are talking about federating models, it's applying everywhere. We had a good, for the second one, is about stationing on the alignment. So using the alignment, we have definitely a linear infrastructure as a road, as perhaps in the airport also, we have perhaps things like that. So identify what is the chainage, the KP, the mileage, it depends on how we call it. But at the end, it's to use the track alignment in order to make the relationship between the fact that one item is positioned in the earth with X, Y, Z coordinate, and this chainage, and create this discussion between both positioning systems. That's a very key thing. It's crucial for the railway, and it would be also crucial for other domains. That's what we think, and it's very in echo with Ronald showed us two presentations ago. Sorry, if we can, and the last one is the cabling for railway. We'll come back on it. I will be short. So thank you. If you can switch to the next slide. I will go perhaps a bit more into the details. So when we are talking about the federation of model, it's very focused on the subsystem of the railway. So we are talking about energy, we are talking about the track works, the signaling, the telecoms. And the key message here is that when we talk about that in our own railway system, it's okay. We are facing some challenges, and we think that the challenges that we are trying to solve will be the same if we enlarge the spectrum and we see what will happen with the building, what will happen with the different systems around. So at the end, the methodology that we'll develop within this 1 year program, we think that we can reuse it, and we need to also feedback this process with the other domains. So that's for the, I don't know if you can just switch to the next slide, which is again talking about this model federation. We have this process map that is detailing what we expect. This process will be again detailed by Shi on the last part of this presentation. So that's an example of what we did and the objective of this model federation. The next slide is showing the stationing, the one that I just I gave you some details about that. So it's very key, as I said, very crucial for the track work and the railway industry to have something which is fit for this very special purpose. And it can be applied to the bridges, to the tunnel, to the perhaps to the tarmac of the airport, or many things. The only thing is, when we are talking about railway, we have definitely this challenge of having one track, another track, perhaps a third track, perhaps something that is crossing both. So that's where we think we can bring something to the other industry, because we have perhaps the most constraints environment for this question of what I call chainage, what the other can call manage, or we can have this discussion about the wording. The next slide is emphasizing this point and showing that we have different challenges on this matter. The first one is to place an equipment based on the KP, the kilometric point. The other one is to so it's to place it. It's also to fine-tune the positioning of this one. Is it on the right side? Is it on the left side? Is it with an angle? That's this type of question that we try to reach out with the work done in the frame of applying for IFC for rail. And the last one is to interrogate the equipment. It can be a signal. It can be many things around drainage item. And here it is to interrogate this item and to have the right information, basically to have the XYZ and also the mileage based on the track. And the last slide before giving back the mic to Shi is about the cables and the cable routing. It's a key challenge, and just to give you some insights, we have to know where are the cables for sure. We have to understand how they will be embedded into the mask, into the cable routing. It depends of the type of cable routings we have in the project. But in addition to that, we need to be able to do electromechanical, magnetical, compatibility check. That's this type of usage that will change definitely our industries we are able to face and to reach this challenge of having. That's the last slide.
So Etienne, I guess, could go to the next slide.
Yeah, don't have the. Yeah, thank you for that. That's the layouts and the challenges we have. Yeah, I'll let you finish. Sorry.
Okay, I'll try to catch up very quick. Okay, that's the first part about the project method. It's one part of this project actually is to define a method. So we have this 3 business case work, and also we also need to have a process to define the requirements for these business cases, and then continue this process about to implementation, then to validation. We also get a lot of requirements and challenges from stakeholders about this method. So first of all, this method needs to be general. It needs to be a general method. So it's not only applicable for these 3 business cases, but also can be used by stakeholders to define further use cases. And we will use this method. We expect to use this method to support defining requirements in contracts. So it should also then support automatic rule checking for IFC files. Should also support defining requirements for functional software features, and also would like to ensure the quality of this process. Then should ensure the traceability between requirements and validation methods. So this are all these requirements and challenges that we have received from stakeholders and also from domain experts. Okay, next. So we together worked with buildingSMART to have this 5-step approach. This is just high-level steps. So firstly, we have this business case overview. Then we would define the business case formalization. Then then continue to define the requirements. Then we would define test cases and the rules. Then we would expect to collaborate with software vendors to implement. And then at the end, we do this validation. Next slide. Yeah, okay. I'm not sure whether it is readable or not, but this is very big diagram. Okay, let's kind of look at this one, maybe easier. So just regarding tooling about these things, for the first step about business case, we would use just a text document about the background, scope, and purpose. Then for the business case, we would use the enterprise architect to define process maps and also define use case diagrams. Etienne has already showed some process maps. And then we would go further to define requirement definition. We will also use enterprise architect to use SysMail to define requirement diagrams. Then all these things will be linked to test cases and the rules. We would use this GitHub, mostly the GitHub from Implementer Forum, to define test cases and the data sets, and also use this BSI validation system to define cooking validation rules, and possibly also IDS and BSDD rules. At the end, we also would going to do the validation based on the BSI validation system. Okay, the next. Yeah, so we would like to, this is some challenge actually, we would like to coordinate between the business cases, because there would be a lot of redundant requirements. So we would like to keep to make the requirements consistent among these business cases. And also this will also easier for us to define test cases, and later on also for software vendors, much, let's say, straightforward to create IFC files. So we need to do some coordination. So all the requirements are collected in a central repository, as we call it the requirement specification. And then also based on the requirement specification, we will define test cases and data sets, and then use then create rules to check this. To check the produced IFC files. Next. Yes, so this method also ensures traceability from requirements. So from the process map, we would trace the process map to the use case to the use cases, and then each use case will have the specified requirements, and then requirements is linked to test cases, and then test cases is linked to all the specified data sets, the specified rules on the GitHub. So we use this kind of ways to ensure the traceability from requirements to validation. Okay. So the next step. Is like, we have all these business cases ready, and also this method. Of course, during this process, we will continue to improve to further specify the business cases and also improve this process. And now we really would like to call for participation. I think this is probably some people already seen this page before. So we have a project website from this link. So from this link, if you are interested to join our project, you can subscribe it and give your contact method, and then we will contact you later. And once we decide the further steps about the organization. Okay. So thank you.
Thank you, guys. That was great, but I'm sorry we had to rush you. Now I'll hand over to Christophe. We're going to go a little bit over time, so my apologies for that, but I think it's better to...
So we try to stay in line. So what we want to show today is what we have introduced in terms of perspective of test instruction for the domain of bridge. And it's important because Jim mentioned it could be some redundancy. Yes, redundancy, but some difference too. And the details are very important, and we are going to explain what we are doing. Next slide, please. So what we are going to introduce is based on a domain expert working in mine with a contractor, national administration, designer, commonly with software vendors, Alplan and ACA. And we prepare the job with Sergey, which is also involved in different projects in tunnel and so on, and element-based reference view. And the presentation will be done commonly by me and by Michelangelo. We are going to introduce some element of what we have verified in terms of feasibility of tests. Okay, next one, please. So the input of the works is what was done in the IC Bridge project, IC for the 2, and we are using the report regarding the first work package about the requirements and list of use cases specification. And secondly, the element of conceptual model regarding the georeferencing. This documentation, unfortunately, there is no one from H2 here, but it was based on two approach. The French one with mine documentation, and second one coming from the Federal Highway Agency, and we merge this technical documentation in single one. So maybe a single one. That is very international approach, and we appreciate very much the work done in US about the specification. Next one, and I think will be it will be very important, very important. The final step of this project. So what are the objectives? To define the exchange requirements regarding the question of element georeferencing and what is specific for bridge. Then to describe the list of tests to be relevant for this to adapt to element-based reference view. And what we want to show here is what is the feasibility and the gap about where we are today in terms of view about the test instruction and what it was mentioned in the previous presentation about what is the methodology to accept and to verify that. So that means that what it is still to be done on this project is to define the list of TT and conceptual template and the methodology whereas as it was presented in the previous presentation. Next slide. So what we are going to show is something important, is representative of 70% of usual bridge. So it's not very special, but it's very important because it's to verify that for existing asset, it could be used relevant. And that is very important. And what we are going to show is what it is very typical in terms of requirements to be exchanged with the different step of design. Next slide. So I'm going to show what we want to test, and we will verify with Michelangelo where it is. So where it's very important, what we want to show, next slide, next one, is we have on the bridge two alignment, at least two alignment. The first one is the alignment coming from the road or the track, and the alignment of the bridge. Second, then that is very important. Then, next slide, next, yes, next again. And then you have also some other element of alignment. Next one. Okay, next one. You have on the top, you have the level and the alignment of the road, including pavement. And if you want to apply that to the bridge, you have to take into account that the bridge is designed without the pavement. And all of the references are not related to the red line coming from the road, but a dedicated red line deduce of this one is what we have to test. That's the reason we say we can have some redundancy apparently, but in reality, you have some detail to be verified about that. So take care when we are saying about redundancy of the test, because of course, as it was said, that the details with the devil is on the detail. Next slide. And what also is what we have to verify, that a bridge is to go across something. So we need to be able to verify the clearance between the existing and what you have to be and the new structure. Regarding the verification about the crossroad and the vertical alignment. Next one. And also about the clearance, about the orientation and so on. So we need to have all of this information detail combining with the existing, sometimes existing, or another one structure regarding that. Next one. And then on the bridge, you have at least three reference. The first one, next one. There's global coordinate geodetic. It's not Cartesian. I want to insist that because there is a confusion in the IFC documentation about that. They are using IFC Cartesian to speak about not Cartesian, but geodetic. I think that will be some trouble in the future with that. We have to take care about that. You have the local Cartesian to be used. Next one, of course, because most of the structure are designed in a local coordination, local system of coordinate, and we have to represent that in the global coordinate geodetic plus the linear referencing. And in linear referencing, you have stationing and chainage, but you have also measuring. And we are going to show that with Michelangelo. Next one. Okay, and what I say, chainage station, linear placement along radial. We are going to see that with Michelangelo. One. So the next presentation will be in three parts. The first part is to show the spatial decomposition of a bridge, first of all. Secondly, the aspect of georeferencing. And third, the question of reference to the semantic of the bridge and so on. So the mic is
Thank you, Christophe. So yes, let's start with the bridge spatial structure and the object decomposition, which I think it's quite an easy thing. So next slide, it will be a video, if you can play it, please. This is not the video, of course. This is it. So yeah, what we have done is that we have taken the test instruction from Christophe, and we tried to implement, given our experience also in the other IFC 4.3 projects of rail and infra. Because the good thing about this standard, one of the good thing, of course, is that the same concepts applies regardless of the kind of linear infrastructure that you are designing. So alignment and other stuff will have the same meaning, and we will see in the examples. But as I said, what we have done is try to implement those concepts of the test instruction, and let's start with the special structure, which with the new standard, the IFC 4.3 is very flexible. There is nothing special about it in this example because there is no special need for this model in particular, but based on your use case or being used, the user can go as specialized as he wants. Here we have only the bridge foundation, girder, structure, and the deck as a facility parts of the IFC bridge. And then we have object decomposition. So each element assembly is part of those special structures, and of course may contain different objects. For example, here for the bridge structures, we have the assembly with the pier cap and the pier stem. And of course, everything is let's say mapped according to the new schema. So classes, predefined types, attributes, and so on are the proper ones. And so this concept of object decomposition and the special decomposition applies to every part of the model. Here we are at the foundation. So again, we have the assembly, and here we have a decomposition of the pile cap, for example, the base slab, and each pile in this example has been designed on its own. And again, everything is mapped accordingly to the new standard. So nothing special here. If we can go to the next slide. Yes.
Why we could start with that? Because the question of decomposition means that all what we're going to show after that has to be also applied for the full breakdown of that. That's why we are specific test instruction, and where is coming the difficulty for the next step of the project is to define the methodology of testing and to accept the result of that. That is still to be done.
Yes, and yes, next slide. Yeah, let's go more into the IFC 4.3 core. Let's see about the road alignment, local and linear placement along the alignment, and the project global positioning. So next slide, it will be a video. So yes, we have talked about two different kind of alignments, and here you can see that we have the bridge alignment and the road alignment that are one on top of each other. And as we said, the bridge is modeled without taking pavement into account, for example, so one can refer to one or the other depending on what he or she has to model. The good thing about another good thing about the standard, of course, is that the alignment is defined semantically and geometrically, which means that it is decomposed in all of its segments with all the data available semantically in the IFC model. And this is a good thing for the end users, which have their data in a standard way, but also for software vendors. Because, for example, we can create functionalities about this, for example, to extract data and for example, create drawings. And this is, for example, something useful for the stakeholders, because we found during the storylines that we have produced in other projects that this helps a lot the stakeholders to visualize their data, because they know about how to read their data in this way with the drawings. And so also, yeah. Yes, and here we are going ahead with the examples. Here is the super elevation. We used IFC annotation and the super elevation events. And here is the use of referent and the linear placement, which will tell you the mileage along the alignment where this object is placed. So we have seen this in the previous slides from Christophe. Here we have the chainage example. Again, we can place along the alignment with the use of the linear placement. So we have the mileage. Geometrically, it can be anything really, but the important thing is that the semantic, it's in the file. When it is about geometry, there are different kind of things that we can do. This is a sweep along the alignment, so we know where this sweep, where this slab starts and where it ends. And we have seen about coordinates. So of course we have local coordinates, so we can see the local coordinates of the object where it is placed. But also on the IFC side, we have data about the map conversion whenever we want to go from the local coordinates to the geographical coordinates. So the data is in the file. You can go and transform the coordinates accordingly, given the information in the IFC model. And the other slide, it will be the last part. So next slide, please. It's about properties, because we have seen mostly semantics and relationships and the geometry, which was an acceptable level, depending on what is your use case. It can be more or less detailed, but we like to keep geometry and the data separated. So we also have to add data and meaning to the entities of the model. So what we have done is that we have used a connection to the BSDD, and in particular, we have used the mind BSDD to classify and put some properties on the entities. So I don't know if Christophe wants to say something about the content, the actual content of the mind BSDD. So
the content is very simple. No, the content was done during the process of developing the IFC bridge, and we are using the part of the documentation coming from US again. That means that it's possible to compare the definition, and also part of the approach to implement of a certification. That means that we have to combine at one moment the geometry and how we can attach the semantic for that. So I agree with Evandro that it's not so simple, but I mean, with the fact that we have the question of BSDD and the possibility to plug directly to BSDD, I mean, it's a way to simplify the methodology and to just have to work on the requirements of what we want to verify.
So yes, next slide, please. It will be the last video. Yeah, it is about, so if you can please start the video, it is about the connection to the BSDD, as we said. So we add this model, this bridge model, and then there is the mind BSDD. So what we can do is that really the point is that you can take an IFC file produced by any software, any authoring tool, and connect to the proper BSDD. In this case, it is the mind BSDD, and you can start doing the search in the BSDD, and you will be able to select the objects and start to applying the classification. So here we are just connecting to the BSDD service from buildingSMART. This is the hierarchy. It is a flat hierarchy. In the case of the mind dictionary, there are other domains which have a hierarchy, like parent and child relationships as well. But the important thing is that you can look into the dictionary and apply those classifications, so you can start classify actually your object with your classification. And what the BSDD allows to do is that it will give you the property sets and the properties that you need to put the values in. And this is a good thing, because this workflow ensures the quality of the data, because you cannot go wrong. There is no possible mistakes, because the information about the properties, their names, their codes are in the BSDD, so everything is automatic. And this means that the quality of the model, the data in the model, will be very high. And then there are a lot of functionalities. Of course, this is more about the tool. You can see what has been classified, you can assign color scheme, and so on. But the important thing is that the user can always, at the end, download the IFC model or use OpenCD APIs to go to the next step. Because if someone asks you to classify some models, some IFC models using BSDD, is because probably you are in an OpenBeam workflow and you are only part of this flow where you will hand over this model to the next step, maybe for validation, maybe for aggregation of different models, or maybe for further editing. So that will be it for my side. I will hand over to Christophe for any conclusion.
Thank you a lot. Thank you a lot. I think, I mean, I was very impressed by that because, I mean, we work with that. And I think I want to dedicate this presentation to Professor Yabuki, who was the first one to think about IFC for bridge. And now where we are, we succeed, Professor.
Thank you very much. We have to say that we're moving ahead in leaps and bounds, and it's really encouraging. Thank you for that, guys, for both presentations. We're now overdue for lunch, so I'll close the meeting. Thank you.